Welcome back to 6.2, 6.3, Graphing Systems of Linear Inequalities. Let's begin. So in 6.1, you learned how to graph one linear inequality. In 6.2 and 6.3, you have two linear inequalities. I've written down the steps here. Let's read through them first, and then we'll put it into practice in an example. Step 1 is to arrange each equation in the form y equals mx plus b. Then you are going to graph the first inequality. Next, you will perform the test and shade the appropriate region for the first inequality. Second, you will graph the second inequality, perform the test, and shade the appropriate region for the second inequality. We are looking to, in step 6, find the overlapping regions for possible answers, and if there is no overlap, then no solution is possible. So our end goal is to find x and y coordinates that work for both equations, okay? And we do that by finding the overlap in the shaded regions. So let's give that a try here, okay? So I've got a graph on the next page. I'm going to go back and forth. The first equation is y, right here. Y is greater than negative 2x. So in y is greater than or equal to negative 2x, that's a plus 0. So 0 is my y-intercept. My slope is negative 2 over 1. So the rise of negative 2, run of 1. And here is my, here is my line. Okay? So we've graphed the first inequality. Now we have to perform the test to see whether the solution set is above the line or below the line. Normally we use the numbers 0 and 0 as our test number, but we can see that number's on the graph this time. We can't use that. So we just pick a random number. We can use here 1 and 1. Looks like a perfectly valid test point. So the test is for 1 and 1. If I put a 1 in for y and a 1 in for x, I end up with 1 is greater than negative 2. Is 1 greater than negative 2? Yes, it is. So then we can shade everything above this line. Okay? So we finished step 1. Now we go back. Now we're graphing the second inequality. The second inequality is negative 3 is less than x minus y. I want to get into the form y equals mx plus b first, so I'm going to add y to both sides. You get y minus 3 is less than x. Then I'll add 3 to both sides. Y is less than x plus 3. Okay, now this we can graph. Y is less than x plus 3. Okay? My y-intercept is 3. My slope is 1. So a rise of 1 and a run of 1. And I connect my dots. Okay? Sorry, that line's not super straight, but you get the hang of it. Now we need to do our test for line number 2. So we have to pick a number that's not on this line, but somewhere below it or above it. Here we can use 0 and 0 as our test numbers. Again, you can use any number above or below the line. If I put a 0 in for x and a 0 in for y, I get 0 is less than 0 plus 3. So 0 is less than 3. Is 0 less than 3? Yes, it is. So now I can shade because the test point was right here, I can shade everything below this line. Now the final step is to find the overlapping regions. So we are looking for where is the area that both graphs, both solution sets overlap. And the answer is, I'm just going to use a red box here. The answer is everything in here. Everything to the right of the black line and everything below the blue line is our solution set. So we'll highlight that in red. So if you were asked to give possible answers for these two graphs, you would have to choose anything in the red region. So you could choose 5 and 3, or, oops, let's use black. You could choose 5 and 3 as a possible answer because that's in the red region. I could choose 8 and 1, for example. I could choose 10 and 7 if I wanted.
So there's a test and substitution?
Not a test, you've already done the test, but if the question asked you for what are some possible values.
How do you know that's where they are?
Because I can see, I'm just looking at the numbers. I know that I did the tests, right? So I know it's everything to the right of the black line and everything below the blue line. So the overlap of the yellow and the green was right here, right? So that means that anything in here are possible values that will keep both of these true, okay? So I just look at the numbers on the graph. 5 and 3, I could choose 5 and 1, I could choose 4 and 0. Anything that falls in this red region would be possible answers that would be true for both equations. Okay? Let's try one again here. Okay? We're going to do 5 of these today. We'll do one more together, and then we'll get you to try one on your own. So the first one says x plus 3y is greater than 0. Okay, so I want to get this one into y equals mx plus b form. So I'm going to minus x from both sides. 3y less than negative x plus 0. Divide both sides by 3. Get y is less than, or sorry, greater than or equal to negative x plus 0. Okay. Now I can graph that. My y-intercept is 0. My slope is negative 1 over 3. So I've got y is greater than or equal to negative x over 3 plus 0. Okay, so my y-intercept is 0. My slope is negative 1 over 3, so down 1, and then 1, 2, 3. I connect those dots. Now I do my test. For a test, again, I can't choose 0 and 0 for this one because it's on the line. I'm going to choose 2 and 2 as my test point. 2 and 2. So I'll be left with 2 is greater than negative 2 over 3. If I sub a 2 in for x and a 2 in for the y. Is 2 greater than negative 2 over 3? Yes, it is. So that means that because this test point was valid, I get to shade in everything above this line. Like so. Now we go back and we do number 2. This was x plus y is greater than or equal to 2. We want to get the y by itself. Negative x plus 2. So our y is greater than negative x plus 2. Greater than or equal to negative x plus 2. Maybe I'll switch to blue for this one. My y-intercept is 2. My slope is -1. -1 rise, -1 run. I'll draw my graph like so. And now I'm looking for my test for the blue line. So here I'm going to use my test number as 0 and 0. Again, you can choose any number you want. I'll be left with 0 is greater than or equal to 2. Is 0 greater than or equal to 2? No, it's not, right? So that means that this point here is not in the solution set for the blue graph. So we can't shade below the blue line, we have to shade above the blue line. So I'll do that in green. Everything above the blue line. Now, the final step is to look for any overlap. So the overlap occurs and anything that's above the black line that's also above the blue line. So I can look over here. If I had to write down possible values, I could say anything that's above this blue line. So 2 and 4 could be a possible value. Maybe we'll put our possible values in red. 2 and 4. We could use 5 and 3. We could use -3 and 7. Anything that falls above the black line that's also above the blue line are possible values. Okay? All right. Please pause at this point and try this one. Try this one yourself. So if you don't have graph paper, just sketch a little graph on your paper. Please pause and give this one a try. All right, I'm going to start graphing it as well. You can just take a look once you've got it. The first one is y. The first line is y is less than or equal to -x minus 2. So my y-intercept is -2. My slope is -1, so rise of 1, run of 1. Connect those dots. Now I can do a test. I'll do my test as 0 and 0. I'll end up with 0 is less than or equal to -2. Is 0 less than -2? Yes, it is. So that means that everything above this line is a solution set. Then I will go to the second equation. 2y, actually let's use blue. 2y is greater than or equal to x. We'll get y by itself. Y is greater than or equal to x over 2. Y is greater than or equal to x over 2. My y-intercept here is 0. My slope is 1 over 2, so rise of 1, run of 2. Connect those dots. Not my best line, but that's okay. Here is a test number. I'm going to use 6 and 0. Just for something a little different. If I put a 0 in for y and a 6 in for x, I will get 0 is greater than or equal to 3. Is 0 greater than or equal to 3? No, it's not. So 6 and 0 is not in my solution set, so I have to shade not below the line, but above the blue line. Therefore, the overlap region is right here. I'll trace it in red highlighter here. The overlap is above the red line, or above the black line and to the left of the blue line. So the overlap region, anything in there. So hopefully that is what your graph looks like. Let's finish with one more here. So we have 2x plus 3y is less than or equal to 9. We get the y by itself, minus 2x from both sides, divide by 3. Okay, y is less than or equal to negative 2x plus 3. Y is less than or equal to negative 2x plus 3. Oh, sorry, negative 2 over 3x plus 3. My y-intercept is 3. My slope is negative 2 over 3, down 2 over 1, 2, 3. Connect my dots. I do my test. I'm going to use 0 and 0 as my test number. 0 is less than or equal to negative 2 times 0 plus 3. 0 is less than or equal to 3. That is true. So therefore, I get to shade everything below the black line. Go back to my other equation. Y is less, y minus 6 is greater than or equal to 1. Add 6 to both sides. Y is greater than or equal to 6x plus 1. Y is greater than or equal to 6x plus 1. My y-intercept is 1. My slope is 6 over 1, so 1, 2, 3, 4, 5, 6. Run of 1. Okay. For a test point for this one, I'm going to use 5 and 0 as my test point. Again, you can choose any test point you want, as long as it's not on the line. Get 0 is less than, 0 is greater than 6 times 5 plus 1. 0 is greater than 31. Is 0 greater than 31? No, it's not. Therefore, I cannot shade on the right side of the blue line. I have to shade on the left side, right there. Now I'm looking for the overlap region. My overlap occurs below the black line and to the left of the blue line. My overlap region is right here. Okay, so anything in this red box will give you a possible answer. All right, that brings us to the end of today's lesson. Your assignment is in the workbook, pages 155, number 3, and well, number 1 and number 3, and then also page 159, numbers 1, 2, and 3. When you finish this, let's go to Microsoft Teams and work on the Chapter 6 review, as we will have our exam next class. Thank you. Have a good day.